A little bit about Cameron and I. This is Cameron Cedar. Cameron, tell everybody what you do.
I am a technology strategist. I live on the West Coast, and I've been with SUSE for almost 12 years now. And I work with some of our strategic customers on storage and on OpenStack and some of the new technology with SUSE.
Thanks, Cam.
You bet.
So my name is Jeff Price. I'm a principal architect with SUSE Consulting in North America mostly, but I do travel around a bit, quite a bit, actually. Just glad to be here. We are having a lot of conversations with a lot of customers about this new buzzword called DevOps. And as you find out with buzzwords, right, it's, the definition can change depending on your location or who you're asking. So we're going to try and dispel some of the, I guess, the mystery of DevOps, talk about use cases, talk about things to the story of continuous integration, continuous development. Yep. If I could ask, could somebody pull the door shut, because that would help out, because we tend to get loud. Thanks, Brian.
Not to scare you a little bit, but...
Thank you. Thanks.
All right. This is a simple fly swatter.
Does everybody know who Rube Goldberg was? Okay, so Rube Goldberg, famous artist. One could say he was an inventor, but I think the reality was he had a very inventive mind. He would come up with these fantastic contraptions to do the simplest thing. So it could be, in this case, swatting a fly or cooking breakfast, what have you. And it would be an unbelievable orchestration of a million pieces and parts, often fraught with a lot of risk, meaning there was no, I guess, guarantee that it would always work the same way because of chaos theory, what have you. This is kind of what DevOps looks like to a lot of people. So the explanation on the left, right, is the very complicated procedure to swat a fly. So I take it you guys can relate to that, right?
There's a few chuckles out there, so
okay.
I'm sure you can relate.
Go ahead.
A common day in the life of a developer. Let's kind of explore that perspective a little bit. You tend to want to be in front of your screen, just like this guy here. You want to be in front of your screen, and you want to be alone, sometimes with the lights dim and turned down a little bit, so you have your headphones on and you've got your favorite music on and you're concentrating just on your code. And that's all you like to focus on is your code.
Beautiful.
And you don't like to have an interruption from the outside world or from operations, or you don't like to hear something is going wrong with your code.
But from your perspective as a developer, it tends to be myopic. It's about what you're doing, right?
That's right.
But of course, you're employed, right, to drive a bigger picture than your own picture. So I guess the next slide kind of talks about the descriptions of operations, right? So you've got developers, they're making their code. You've got operations who are maintaining the operational quality of an environment, and they're sometimes opposed, right? Although they are employed by the same person or the same corporation, they have very different ideas about what's important. So this says, it's operations is slow, and they don't, it takes them a long time to deliver. They're unpredictable, and so the mix here is you've got this combination of development people and operations people, and I guess my favorite way to describe DevOps is just in a quote. Remember when we used to work together? Right? So I remember a day I was in a systems operations group. I took care of servers, and my buddy was in the network team, and he sat right across from me, and I'd set up a server, and a service would be running, and wouldn't be talking on the network until I said, "Hey, Tom, can you open this port for me?" He's like, "Sure, Jeff." Everything starts working. So remember when we used to work together. Unfortunately, teams get bigger, companies get successful, they start adding a lot of people, and they start adding a lot of managers, and then they start adding a lot of floors, and then the network team, Tom, my good friend, is now 3 floors away from me in another building. And not as convenient, not as operationally efficient.
And there might be some requirements that you have, some red tape you have to go through.
Process.
So,
really, it's all about communications, and the focus of operations people is that guy playing Galaga?
yeah, that guy in the lower left, that's probably what he's focusing on, really.
So the operations people just care about stability, keeping something up, making something repeatable, making something, green, right? Keeping all the systems in a...
I'd just like to see green.
So status of servers, they have to report on uptimes. They have to worry about, meeting objectives, and the 3-letter acronym of choice for operations is what? SLAs, right? So it's about SLAs. They have to report, they have to keep things consistent. And then you have the dev teams who just want to deal with their code, they want to deploy it, they want consistency, they just want access to their systems so they can try their new stuff, right?
That's right.
Sometimes you have to pick a side, right? So which side are you on? Who associates more with the developer side? Okay.
Developers.
All right.
Couple in the room.
So who associates with operations side? So who plays the long game and associates with both, right? Because at the end of the day, it's kind of about the business, right? So what are some of the common complaints of developers?
All right, developers, what are some of your complaints?
Not saying we're going to solve your problems. We'd just like to hear what they are. Anybody?
Speed and interruptions.
Interruptions, right? You want to be left alone with your code. You got to get this stuff
in your
done.
dark room.
You have your own stuff that you're trying to do. Release management, right? You've got the next version that you're working on. Anybody else? I'm sorry? Feature creep? What was that?
Feature creep.
Okay.
Feature creep.
Yep. Like the latest new thing, I want to put in this new system that has these bells and whistles on it, and it's beyond the scope of your release
We need this new
management.
feature just because. Just because.
Right. Some other complaints that developers have, they want access to the latest tool sets, right? I want to write my code in PHP 7, and this version of Slash only has PHP 4, right? I need PHP 7, right?
That's right.
Or Python this and that and what have you. So access to the latest tool base, right? So what about
Operations complaints. I think there are more operations people in here.
Sure, what about those feature?
The consequences of everything that you stated. You want PHP 7, but guess what? It wasn't in production. So now you want to bring that garbage
Correct.
to production. So
Yeah.
how are you going to do it? And how are you going to keep the lights and do not interrupt the lights on?
Okay. So Jose is saying, basically, how do you give them access to this latest version? How do you trust that it's as stable or as secure as the last version? How do you meet with the ongoing demands and the rapid development of new tool sets, right? The latest version, I need the latest version of this because of this. Yeah, but we don't have that in our code base. The operational standard is this version of SLES, and it includes these pieces and parts. Some of those things that we're trying to address with Package Hub, some other things you'll hear about this week.
Right.
So,
Yeah, you might run into complaints around gosh, how am I going to keep that updated too? You know, because I have this specific version that you guys are requesting on the developer side, but
what if it requires an outage to your application base? Sure, I'll upgrade to latest version of whatever, but that means I have to schedule downtime to update it, roll that update across multiple systems in a cluster.
Not only that, maybe I have to get that version from some tarball, and it's not from SUSE.
What's a tarball? No, I'm just kidding. So, how do we address this?
DevOps.
So DevOps is really taking that wall of confusion between developers and operations, right? Bringing them together. Remember when we used to work together? Right. So this functionally is what the business, the long game, what the business wants, everybody to kind of just get along, right? But functionally, how to address ways to do that with tool sets, delivery practices, paradigms. I said paradigms.
Paradigms.
That's 20 cents because it's a pair of dimes.
So the DevOps way.
The DevOps way. Hey, how you doing?
We're working together now.
So development, what do they care about, right? They have 3 out of the 4 of this stack, right? Development cares from the top down about the code, about the applications, having a standards base, right? The OS and what version, so they know what tool sets they can develop with. Some of those concerns actually overlap, right? You have operations that care about a standard platform. I want this hardware, I need this BIOS revision, it has to be, delivered in a sane way so I can repeat it, I can document it, so that when I hire somebody new, they can follow those same processes, and I have consistency. Gives me a hardware, OS, and a application bed, framework that I can lay down my code, all right? So, typical paradigms. Paradigms that are addressed by development and operations working together. So, image management. Is this common to you guys where you're taking that common base? I want to develop my own gold standard of SLES 12 SP2, and I want to lay it down and I want to have a consistent rollout so I can upgrade my systems, roll out new systems, and always have the same base.
Image, same base
right?
image. Absolutely.
So how are we addressing some of those things, like our just enough OS, right? A great building level, secure because it doesn't have anything, or everything, or extra stuff on it.
Making the OS modular with SLES 12.
So what about packaging?
Packaging.
Packaging management. And what I mean by packaging is I've got my code that I'm writing as a developer, but I want to deliver it in consistent format that I can put onto all of these standardized systems that I'm doing in my image management. How do I get that code into the image? How do I make sure that when I develop my code, it goes through a standardized process, builds in a consistent way, and then I can actually apply that in a standard format to my latest version of whatever my gold standard is for SLES 12 or SLES 11 or whatever.
Yes.
So packaging, right? What about patching? Well, now that I've got this gold image and I keep adding my code to it, well, maybe I'm just applying updates and fixes to my code. Well, could I package those? Could I distribute those as updates? How do I keep all those gold standards continually up and running and safe and secure, compliant with the latest patch mandates that come down, whether it's like healthcare, HIPAA, or Sarbanes-Oxley, or PCI for retail.
That's another paradigm you can put on there, right?
Sure, upgrades. How do I go from one version to the next consistently? How do I maintain uptime even when I'm doing these upgrades?
SLAs. Right.
Sounds really complicated. Is it complicated?
Let's enter into the SUSE approach.
So a little bit about SUSE. It's this company I work for, but we've constantly been worried about these very same things, right? Because we are a development company. Did you guys know what SUSE stood for? It's actually an acronym, right? Yeah, so SUSE has been doing DevOps from the very beginning. if we didn't have a tool that allowed us to be agile and put things out consistently, we'd build one. In fact, we'd build it as open source and make it available to our customers as well. So there's a lot of tools that you might have heard about. There might even be some tools that you haven't heard about, and we're going to talk a little bit about them. But at our very core, we're a systems and software development company, right? And that's right in the name.
Right in the name.
So this entropy, this infinity symbol of DevOps, you know, where you're worried about release management and operations and deployment.
Yeah, whether we knew it or not, we started with DevOps from the very beginning, from the very core.
Right.
So we're more than just a Linux distribution. We have tools available that fit within all the quadrants of DevOps that help you drive your DevOps environment.
Remember that old commercial, Rolaids, how do you spell relief, right? Right?
Yes.
Yeah. So how do you spell DevOps? S-U-S-E, right? So our approach and our tool set, let's talk a little bit about those.
So of course, our core, we believe in open source and open development. That is at our core. Open standards, open APIs. We believe in making sure that our software that we build has open APIs that you can plug into to really automate your DevOps environment and really plug those into your DevOps environment. Open protocols, languages. One thing that happened in the SLES 12 when it was released was YAST. Was completely, we removed its core language and replaced it with Ruby.
Yeah, it used to be
moving into
built
a more
as
standards-based.
Wasn't it called YCP?
YCP.
Right, so it was our own C
our own
type
thing.
language. But now we've, I guess, replaced it. Everything's Ruby.
Everything's Ruby.
Okay.
And
So it's red and shiny.
bright and shiny. But everything that we create has that enterprise focus. So this, to some of you, it might look complicated or scary, however you want to look at it.
So the deployment operations, DevOps, people are constantly trying to take developers, take their development, put it into builds, have a consistent test bed so they can get repeatable and reportable results, and then deploy that in a consistent framework. So some of the tools that we've got, you'll see Kiwi is there. Kiwi is not just a fruit. It is kind of the underpinnings for our image management, and I guess it can do images and
Package creation.
yeah. So it is the base of a couple of our different methods to put things together in repeatable formats. It has a concept of the physical extent and the logical extent. So where the packages and everything get placed in a file system, and then what format or container that is delivered in, whether it's an ISO or
Takes multiple inputs, multiple outputs.
Yeah.
Yep.
So KVM, Zen, these different hypervisors delivery. So the containment of those images, once they get created, you can put them on a variety of platforms in their native build format.
Do we deal with a lot of outputs today?
Creating ISOs.
VMware output. Maybe it's a public cloud. Maybe it's Azure, or AWS, or KVM or Zen on Linux.
So that might look a little scary. Not that scary. That's the wrong slide. Go to the, all right. So here's another version of scary. So I know you really can't read this because it's that scary, but how do people put these pieces and parts together? This is a green print, kind of like a blueprint, only green. A green print that I put together for a customer around DevOps, how they could take, Jenkins and, plugging into a Git repository. They also had another, what do they have, SVN as well, Subversion. They had a retail environment, so they also used SleepPause, which was our point of sale endpoint for doing cash register images. They also hooked into SUSE Manager, so they could develop their own code, commit it to a GitHub. It would automatically sense that that's been delivered. It would rebuild that package in an RPM format because OBS would hook in and see the change. Jenkins helped automate that a bit.
Right.
Once that package was built, it was also presented into our image management, so we could actually build an image with that code in it. It was also presented as a patch to already deployed systems so that you could roll it out with SUSE Manager. Not only that, it was actually leveraging storage, so we could actually store those images that got built, and it took care of several paradigms: patch management, package management, image management, store operations. So it looks kind of scary, and I guess, as we've learned with a lot of big monolithic type infrastructures like single sign-on and identity type systems, the best approach is to do one thing at a time, right? So you have, I guess, a higher chance of success. But if you can build a flow chart, have an idea of what steps you would like to do, the tools are ready to integrate rather seamlessly.
And that's the thing with the monolith, is it follows the common standards that you're following within your organization as well. And so as you're creating this process, it's following those same standards.
Yep. So it might look scary, not like the previous slide scary, but really it's simple. It's taking your inputs and your outputs and mapping them to a logical process in a repeatable fashion. So that Rube Goldberg machine that people see, super complicated to do something simple. Really, the people at the top see it as something, why can't we do this simply? And you can kind of say, well, we can, right? Depends on your point of view, right? It's kind of like Obi-Wan, right? So some of our tools.
Yep. So packaging, this may or may not be important to you. You might have some reasons within your organization to build your own packages and to package that up using our build service.
And why is that important? Consistency, again, right? If you're writing your own code, OBS allows you to actually put in your own signing, your GPG signing as well. So you can actually create your own code, have it built into a standard package delivery format, and you can have somebody else, typically they separate those duties. You'll have somebody, I said duty, you'll have somebody else that will sign the code versus somebody who will package the code. But you can have OBS, our Open Build Service, actually put signing keys on it so that that software now has a trusted source.
Trusted source, yep.
All right.
And you can take that trusted source, plug it into a tool like Kiwi, and oh, by the way, the Open Build Service can also build Kiwi images, so it's kind of an automated stack together. Kiwi's just another tool that's running within that build service environment that you can utilize to actually plug in those signed sources and build your own image out of it, whether it be an operating system image. Maybe you're taking package repositories and building those into an image. So you're creating this golden standard for your environment that you can reuse in multiple ways.
How many people have used SUSE Studio? Anybody? Show of hands. All right. So how many people are Windows people here? Okay, cool, because I didn't want to offend them. But here's what I say about SUSE Studio. Okay, SUSE Studio is using Kiwi under the covers, but it is web sexy on top of Kiwi. Okay, and what I mean by that is even a Windows person can build a really cool, decent Linux image by just pointing and clicking, right? Because that whole mouse thing. It's an excellent way to get into a consistent build. You can then export the actual package list. You can set up a whole bunch of, and we do sell an on-site version for people who want to put their private code in, right? There's also a full open version on SUSEstudio.com where you can go out and add your own backs. I know so many customers that actually build all their own rescue media on this. Put their tools in, add their own splash screen and everything else. Mine comes up with Neo from the Matrix and everything else, right? But I know for a fact, several of my customers, SUSE Studio saves their bacon because they will store their rescue media there, and they're on call. Somebody's like, the server's down. And they're like, just download my rescue media, boot into rescue media. Where's your rescue media? Just go out to SUSEstudio.com, and because they publish things like that. It's a fantastic way to, again, go for that consistency in image format. And since it is a standardized export, you can also import that Kiwi file into build tools that are local, add your own code so you're not publishing internal stuff.
Yeah, so you can have a contained environment that you can develop.
I don't know, AJ, do you like that? Web sexy on top of Kiwi? I mean, all right, cool.
So, I mean, with that web sexy, I mean, there might be retailers or even yourselves, you have developers or operations folks that might not be savvy in the Linux space. And so this is really attractive for them to take a look at this and what they can do, how to carve up their OS and make it their own.
Yeah, procedurally, you can even take a particular instance of an image that you've created in Studio. You can publish it, kind of like a museum, right? It's called Gallery. So you can actually take that standard gold image that you're working on, publish the configuration, and it can sit out there as your gold standard, blah, blah, blah. And people can go out and build it or base the next version on a previous version, add pieces and parts. So
now another open source tool we really don't talk a whole lot about is OpenQA. And this is a tool that we use a lot today on the OpenSUSE side. And SLES. It does a lot of our QA. If you've ever ran OpenSUSE Tumbleweed, it is running through hundreds of different tests, QA tests, on the OS to make sure that things are where they're supposed to be or things are installed how they're supposed to be, or files are in the right locations, things of that nature. It does all of these hundreds of tests before the actual packages are released for use, so that we can get a good idea to the quality of that code before it's actually going to hit our customers.
Sorry, I had a cramp, man. It happens.
So OpenQA could be a point of integration within your own DevOps environment as well. And maybe you are attaching your own application to your images that you're building with Kiwi. So maybe you want a certain level of quality assurance built into your DevOps environment before it's actually released. And you want that automated. You can do that now with OpenQA.
What's next? Deployment. Over that cloud stuff. You know what cloud is, right?
Oh, right. The cloud stuff.
Yeah. There is no cloud. It's just somebody else's computer.
So we've talked about the Open Build Service in quite a bit of detail there. openbuildservice.org. You can go out and download it there.
We're actually, AJ, I don't know if we're actually kind of testing something right now with an enterprise type offering around OpenQA, and we're kind of in development of OBS, right, of the Open Build Service. Yeah. So some of our customers we're talking to them right now about having an offering where we can help deliver a build service for them, supported.
Yeah.
So.
And then OpenQA, we just talked about. Kiwi, we've talked about. We're just way too fast.
Well, no, it's just we're that good.
SUSEstudio.com. If you aren't familiar with it, go out there. There are thousands of downloads or thousands of builds a week that happen on that site alone. So there's lots of things that you can grab from the gallery that's there. Just enough operating system, we talked a little bit about that. This is a way to modularize your OS, take some core functionality of the OS, or a minimal installation of it that only has a few components that you really use. This is great for updating because you have less to update.
It's also more secure inherently because
Exactly.
it's not just that you don't have the service turned on or configured, it's not installed.
Not there.
So it minimizes your security footprint. It is correct. So there's some other things that we're doing in the container space as well. You'll hear a bit about, not to be confused with just enough OS, but things around container systems and, you know.
Mm-hmm.
So just enough operating system allows you to build a really tight, low package count, secure base, and then you add the pieces and parts that you need. The server services that make it a server.
Has anybody here used just enough operating system? Okay, so if you have, yeah, good.
References will vary with other juice installs.
Yeah.
Folks that played around, I think Outline was the main one that people
Okay.
played with because it got super tiny and all this installed for
Right.
various container bits.
Nice. Yeah, it's great.
What's
It's
next?
very useful. So modulars, modular OS, and that's where we come in with SLES 12. I wanted to touch on this briefly because I think it's important as far as we're talking about carving up that OS. Well, we are adding in new functionality to our OS by the use of modulars. I'm sorry, modules, modulars. But they all have a different life cycle with each module. And they're all delivered online. We don't package up separate media for each one of those. So a closer look here to some of our modules. We have a web and scripting module. We have a legacy module, public cloud, the tool chain, which gets updated every year, the advanced systems management module, which is probably going to play a bigger part of a role for DevOps because it includes things like Puppet and CF Engine, machinery, some new tools.
And salt.
And
soon.
Salt
Yep.
will be.
Yep.
Yes, question. Machinery, sure, absolutely. Machinery allows you to inspect a system. In fact, let's skip ahead just really quickly.
Or
We'll
we
go
could just
back.
say, give us a second, we'll get there.
No, we'll skip ahead.
Okay, let's skip ahead. We're skipping ahead.
Just because we like to do that. So machinery allows you to take a profile of a system. And
Even another OS.
Even another OS. It could be Red Hat. It could be HPUX, a Unix system. And it gives you a dump of what's installed on that system, what packages are installed on the system, and also a dump of what's on the file system level as well. It could be something that's not maintained by some of those RPM packages. And so it will give you a list of files that have been created outside of that RPM database that are maintained separately. Okay. You could also have it extract that into a tarball that is an archive that you could actually use to create that system. So once you have this system manifest created, you can utilize that to clone an existing system. You can utilize that to create or upgrade another system. So once you clone it, you can then upgrade it by using an AutoYast file. Machinery has commands to create an AutoYast file out of the manifest file that you created. So once it's inspected, create the AutoYast file, which includes the extraneous files that you might have in that system, in that archive. So you install that system with AutoYast, and then it will include the extraneous files that weren't maintained by RPM and drop those into that new system that you created with AutoYast.
Kind of like an overlay.
Like an overlay. So you can actually, by doing that, you could have inspected maybe a SLES 11 Service Pack 4 system, created an AutoYast file out of it, and used that AutoYast file to upgrade the system to SLES 12, SP1 or SP2. So there's a lot of use cases with machinery. Yes. Comparison is absolutely part of that. You can get really granular, especially with the RPM database, all the networking stack. Everything that's been defined on that system has been captured through the system manifest. And you can go back, and there's a web-based view that you can actually export an HTML format. So you can go back and do a side-by-side comparison in HTML. Which is very helpful.
So, I mean, a lot of the customers that are interested in this are looking at faster, more efficient ways of upgrading their existing older landscapes. Right?
Yep.
There are people that have older versions of SLES and don't want to go through the pain of doing service pack upgrade and then service pack upgrade. With SP2, we've actually tested a lot of skip levels for service packs to make that easier. But the fact is there's still some older systems that having a good way, efficient way to make a system manifest, a really detailed report about what's on that system, helps you move that into a more recent version of the operating system without a whole lot of work.
Yeah. There's a lot of different recipes out there on our GitHub website. There's even a recipe to convert a Red Hat system to SUSE using the manifest file, which is really quite slick. So you can inspect your Red Hat system that might have third-party software running on it, and you can essentially evaluate that for conversion over to SUSE. It gives you the tools that are required to really heavily inspect that Red Hat system to see if that's going to be a fit on the SUSE side. Because there are certain requirements from a third-party application perspective that you may need to either change on the SUSE operating system to adapt, or maybe there is a newer version that you would need to adapt to get it running up on SUSE.
Like new versions of PHP. So you had an application that had an older version of PHP, and you're like, hey, I've got my old PHP 4 code, and I want to move it onto a newer platform because that one doesn't have LTSS anymore. And
right.
In those cases, you'd still have to evaluate your code. Some things might be deprecated, but having a manifest, an actual inventory, will help you make those decisions more intuitively.
To even take it a step further, machinery integrates with Kiwi as well. So you can take the manifest file and build images. So if you had a system running on a standalone server and you felt like that workload would be much better running under KVM or a virtualized platform or even the cloud, you could convert it using Kiwi into a virtualized platform or a cloud platform image. So why is machinery good for DevOps? It's just another tool, right, that allows you to do automation and inspection of existing environments so that you can put those environments into a more automated fashion for the future. Another part of this is
and we only charge like 800,000 per instance, right? Oh no, that's right.
Another part of this is for the operations side, this really makes it easy to really do a lot of troubleshooting. If you are having problems with images coming over in your DevOps environment, having standard machinery images taken before they're delivered, and actually spun up to run in your environment, it makes it really easy to actually troubleshoot your environment because you have a standard inspection report, and then you can go back to a running system that's having problems and rerun that.
Get a diff.
That inspection, get a diff of those systems.
Is this a replacement for support config yet?
So support config.
No.
So support config is for support.
Yeah.
Right. And I think support config kind of grows and changes as we add different products. Also, support config will grow and change based on people using support. So we'll find something that we wished was in a particular support config to help support you, and they will say, hey, Jason, Jason Record, add this to the support config, and then it gets deployed in an update for everyone.
It
So
seems like there's a good portion of overlap to extend one to cover the needs.
well, let me ask you, do you use support config for yourself?
As a company, we collect information from this end of you guys to get help, yes.
Okay, all right. So I mean, and that's a standard practice, but I just wondered if you dug into the actual TGZ that gets created.
Oh, yeah.
Okay, so there's a lot of information that gets put into that. Typically, it's analyzed by our support teams to help them make a faster diagnosis for problems that are common and some that aren't. But that's a good question.
So now we're moving back to modules.
Whoa, back in time.
Back in time. Any other questions around the module stuff?
So modules, when you install SUSE 12, you'll be able to go through the installation. You'll see these other things that you can just check boxes for. Some of them are licensed, you have to pay extra for. Modules are free. It's the extensions that, okay, yeah. But they're,
That's correct.
yeah. Okay, so you'll see them on the same page though.
Yes.
Okay. And here's the thing, if you don't have the code and you check the box, you'll say, where's your code? You don't have it, and then you uncheck it. Right. So, but it is pretty much the SUSE 12 installation has been
Maybe we should put a
streamlined.
$sign in the interface.
Yeah, that'd be cool. Or euro or whatever.
Right.
Yeah. There we go. We have your language selection beforehand. It automatically changes the currency.
Genius.
Put a fade in. Okay. So these modules, these extensions, easy to select during the installation as they come up, and the functionality is there. There's more modules that we are adding. Package Hub is one of these. I guess I talked to Scott a little bit. The best way to describe Package Hub is how many people use the open source, the OpenSUSE build service to find packages. Yeah.
Awesome.
So you're not alone. Lots of people do. The difference is Package Hub is going to be a place for you to find them supported and available within, well, some of them are supported, right? But it's a way to find them right for SUSE instances instead of having to go search for some code that may or may not be maintained over a period of time. My understanding is once it's in the Package Hub, there will be a lifecycle that can be, I guess, depended on. Instead of, for example, OpenSUSE build service, I could have a project out there. Do you really like the package? Using the package? And then I'm like, I'm not maintaining it anymore, and it just disappears, and you're like, where's my package? Well, it was my package.
I think for the most part, I think we're really exploring the capabilities.
Yeah.
Right. Start using it.
We just want to make it easier.
And we'll obviously have more things added on as time progresses.
Maybe
right?
I overspeak. Sorry.
As a point of clarification, can you talk about how modules differ from the SDK? Because a lot of the stuff used to be in the SDK.
I think different supportability.
It's basically, I would say, on the one hand, the modules are supported, the SDK is not.
Okay.
But that's one difference. The other difference, we had put stuff in the things we didn't want to support, or we said different lifecycle symbols in the SDK. So we now have an SDK that's really SDK, it doesn't contain any running stuff. But also the lifecycle. The SDK supports the base, while the modules have a different lifecycle. So we have PHP and a certain version in there.
Yeah.
So every 3 years, basically, you are going to update that one. The toolchain, we update every year and add a new toolchain to get the one out. And that's different, and it's also supported unless it's on the SDK.
So we'll always include a GCC with distribution. And then I think what they're saying, the latest version would be in the toolchain module. So if you want to develop on the latest one, we'll update that periodically to whatever the latest at that time
if
is.
you want to learn more about that, shoot me an my session was crucial.
Okay.
There you go.
Thanks.
So all of the packages for
Thanks,
the
AJ.
modules on the base media, like when you just get your GA/12 to.
Yeah, so these are delivered online. So you would select,
But if we mirrored like locally on the SMT or something.
yeah,
There you go.
yeah, you can.
Absolutely. They indeed not work this. So the idea is that they work unless there are specific requirements or dependencies with the whole lifecycle.
Yep.
So there's no SP1 or SP2 or whatever. It works from GA to
GA forward. So it's a standard repository for all service packs going forward from GA.
I just never talk to the engineering guys to make sure SMT is doing everything.
They're not under the service pack, they're under just the GA release, the SLES 12 release. In the SMT, you would click the modules to mirror down. And the service packs would be separate things.
Correct.
So
Yeah,
the channels
correct.
for the modules are separate, but released with GA. And then the additional service packs come later and have
Correct.
nothing to do with the modules.
Correct. Yep. Completely separated. Yep. Docker. So we talked about the big monolith.
Yep.
And so Docker is starting to, I would say, carve up that monolith a little bit into more of a services approach, which I actually have a session that talks about this in more detail. But Docker allows you to abstract away the OS a little bit and isolate your application and libraries specifically just for that application.
Yep.
So how is it different? I wanted to talk about this in DevOps because it does play a role. Because DevOps, you can actually spin up small services or have things that are like serverless environments that spin up inside your code, where your code will launch a container and then the container will do its work and then shut itself down. So there's a lot of use cases around that in a DevOps environment. So you kind of have to think about that when you're architecting some of your services and the way that you want to move forward with some of those services in your environment.
But it answers lots of questions. Scale, right?
Yep.
Portability,
It does.
right? Flexible integration. So.
Yep.
Just make sure you're not on ext3.
Yes. Coming from Griff, don't be on ext3.
It doesn't clean up the storage, so we keep running out of space on some of the Red Hat boxes.
Oh, is
They're
that
running ext3. Then yeah, the Docker doesn't have anything built into it to clean up images, so to keep building and building and building, but it fails their storage integration to get it off the box.
A few caveats, right?
ext4 are better at us.
Yeah. Who here is playing with Docker? Got a couple? Okay. There's quite a few Docker sessions this week. You'll get a much more detailed or deep dive on from those sessions. So check those out. Talked about the machinery. OpenStack. Who knows what OpenStack is?
Yes.
And yes, we do have a distribution, SUSE OpenStack Cloud. Okay. If you have not explored SUSE OpenStack Cloud yet, please do. If that has not been on your RFP list, put us on there because we do have a distribution. So this is another layer within DevOps. This is going to provide your automation framework, your underlying infrastructure for your servers, your storage, and your networking. Your container is going to be a layer on top of that. This is going to handle a lot of your automation within your DevOps environment. You could, in fact, run your entire DevOps core on top of an OpenStack infrastructure, if that's the way you wanted to design it. But start small, right? we ended up with that big picture.
Yep.
That could be scary, but start small with DevOps. As you enter the DevOps space in your environment, you don't want to start with the big picture. You want to start small. Start with a few components, and then start with a few workloads, and take those workloads and figure out how you can put those into a DevOps environment. Start utilizing some of those open source tools, some of the SUSE tools that we've talked about today. SUSE Manager is another tool. This is going to give you your lifecycle management for your systems.
Sure.
For these images that you're deploying that have your application stack and more.
Patch and configuration management. Now SUSE Manager 3 has Salt stack components in it, Salt.
Right.
So
The
it's a
keynote.
Salt master. We're going to be talking a lot about that this week on the keynote. So
Everything's going to be salted.
yeah. Yeah. Well, keep in mind that humans cannot survive without salt. Just saying. It's a fact.
DevOps needs a little bit of salt or a lot of salt.
So
Depends on how you want to look at it.
there's a lot of sessions this week, and I know this is just your first one. We want to thank you guys for coming. I know the answering of DevOps, answering the question of what it is, the conversations that you have, take a conversational approach, and purpose-built is probably the best approach. Have an idea of what you want to accomplish. You have development going on. You have operations going on. It's a buzzword right now. A lot of people are trying to scramble and figure out what it means because they want to put it in, whatever it means, because it's popular. Everybody's talking about it. Understand the conversation. We didn't show the ZB Lab stuff, but that's an excellent website that kind of, I guess, helps people with the vernacular, the language, the lingua franca that you need to have intelligent conversations about DevOps. Purpose-built, I guess, is one of those phrases that I like. If you can build an outline, step by step, a flow chart, rather, say, I want to do this with this in this predictable fashion. You don't have to build a Rube Goldberg machine right off the bat. It might look like that someday, but as long as it's repeatable and consistent and gives you the actual results that you're expecting, DevOps doesn't have to be this nebulous thing. It's just when we used to work together, right, and being efficient in delivery. So, is that about it?
That's about it. Yeah.
Okay. I guess we're supposed to say, hey, fill out our survey and tell us how good looking and cool we are. In addition to the content and rating that, I'm not going to apologize how busy I've been, but I wanted to personally thank Cameron for saving my bacon on this slide deck, because somebody did most of the work. If you guys have questions, now would be the time, right?
Yep.
Yeah.
So all the SUSE tools, are they integrating with ChatOpsy stuff like HipChat or are other CI tools like Jenkins? Are there integration points and API things that can call out and just
Absolutely. Absolutely. Yeah, there are integration points through APIs.
Even
sometimes
OBS
through Jenkins, and
right?
yeah, OBS is a big place to capture some of that.
So we use Jenkins internally as well, but OBS right now, like the latest version, even has a Git extension in it right now, so that you can actually hook it into. I think that was 2.7. Was that 2.7? That had the Git extension right off the bat. So we're trying to make things logically easier to implement. Putting these things into an open standard of having these APIs for integration, that's kind of across the board. So
integration with all the ChatOps stuff works great.
Yeah.
Yeah.
So one operation room and you can call out all the different things and just have one place to go.
So ask Roger about even some of the stuff that we've been doing here at SUSECON with using Salt and integrating those hue lights. You can actually set up a proxy minion to turn a light bulb on and.
Oh, yeah, they had that bullet point earlier.
Right. So I mean, it's really easy to do. So we talk about network operations centers, and they had these Christmas trees, right? They'd have the status lights for the data center. It's unbelievably easy to build one of those for $60 by getting one of those Hue kits and setting up a proxy minion. You can set states and beacons to have the lights flash or disco party when something happens. It's a great thing to show.
Disco party in your data center.
I mean, it's really, really easy to do. Yeah.
Right.
So.
Good
Any
question.
other questions?
Any other questions?
From the enterprise side, how do you think who is the biggest blocker for implementing with DevOps? The managers, operations, or the developers?
Did you hear the question? I had a hard time hearing.
What was the question, Michael?
I asked who is the biggest blocker for implementing the DevOps?
What is the biggest blocker for implementing Docker?
You said who?
Managers.
Yeah.
Oh, okay, gotcha. Who is the biggest blocker?
I'd say those that don't want to adopt change. It's the biggest thing. Yeah, even with rolling out Git.
Yeah.
People don't want to even learn Git.
It works well enough right now.
Exactly. If I do it this way, I have to change everything. And I'm like, this is IT, you can change everything.
Well, see, that goes back to the monolith, right, in your enterprise, because the monolith is all tied to process. It's all tied to process in your organization. That's a big blocker, and you have to separate that. You have to be able to separate process from services and be able to split those things up. That's where you get Docker injected into the services side, and you can split those things up now. You just have to separate that in your organization.
I think, like, my impression is that our executives, for example, hear about DevOps and like, okay, we gotta do this because everybody else is doing it, like, yes, right?
Ask them what it means.
But they don't really understand what it means. And,
Yeah.
And if it's just investing in the tools, that's not enough. Because
You've got plenty of tools.
we're having a difficult time adopting.
Yeah.
We've invested a lot into the tools.
Mm-hmm.
And I'm like, great, why don't we use them? Oh, because we've never done it that way. Because
Exactly.
we've
You're
changed all our
stuck.
processes now.
Exactly.
And
Yep.
so each one of those managers needs to actually sit down with his team and go, starting now, you're going to do it this way, whether you like it or not.
Right.
And I guess I'm trying to
Get rid of that old tool, that old process that you've been stuck with, because it's not allowing you to innovate. It's not allowing you to be creative. It's not allowing you to do the things that you want to give yourself either a new UI, a new look for your users, or whatever it might be.
But it takes more than just management. I also think it takes like those teams that are doing things a certain way to have an interest to go, if we all got together, we could come up with our own
And
process.
yeah.
so that brings up
This is how we're going to do it.
it's a really good
Yeah.
point. So DevOps
Yeah.
doesn't normally happen as a greenfield approach, right? We're going to
Yeah.
start from scratch and just do it better now. You don't usually get that opportunity. So this is what I meant by purpose built. If you have you ask them, so ask leadership, what problem do we need to solve? Tell us what's wrong, contain it, give it a context and say, let's work together. Remember when we used to work together? Get that common ground of everybody working to solve, purpose-built, a problem that has been defined. You can use DevOps Approach to do that. Remember when we used to work together. Now you've got alignment. You won't necessarily have agreement, but alignment still moves you forward, right, to deliver to that objective that you asked. What's the problem that we want to solve? And why are we solving it? Usually it's because the business is hurting, or we want the business to do better or improve something, right?
Are there any tools or any presentations when you guys talk to customers? At any point, how do you convert this conversation into a dollar sign? Because before I came over here to SUSE,
Yeah.
I used to be the manager, so I can tell you. So somebody comes and tells me, we got all these tools. I go, great. This is the fifth time I heard this in 10 years, and the other 5 only the same thing, and they never deliver. So basically, to me, it would be, okay, tell me, where are the savings? The moment you can show me savings with a dollar sign, I'm hooked. Okay. So this shows me that when this is all said and done, I should achieve X amount of savings. So is there any template?
Right, so then that's your problem statement. I want to save money. Right, so show me how to do that, and then you can define that money. Is this CapEx, right? Am I saving money because I don't have to buy COTS, software tools off the shelf that cost real dollars? Oh, I can use open source because they're essentially free like a puppy, right? Right?
This can even be mapped back to being competitive in the marketplace, right? Not just about money. Although the money part can be a competitive piece.
Well, the other part of that is OpEx,
and,
correct?
Exactly.
So CapEx, capital expenditure for tools, versus operational.
Is just a common denominator.
Yeah.
You can achieve the savings whether it's in time,
Yep.
resources, better usage of the existing platform, etc. But the problem is to take all those talking points. You have to use that common denominator as like total expected reductions on whatever. Here's the dollar figure.
Right.
Yeah.
So I don't know if you all saw this, or as far as rolling out, but Jenkins World 2016 had a really cool presentation of 4 quadrants of DevOps maturity that talks about moving through either managerial based or team based and just adoption on the enterprise scale. And those are a really good presentation. And you can just do a random Google search for 4 quadrants of DevOps Jenkins World, and it'll bring up the PDF with a read.
Cool.
Like 70 slides, but
I'll give it a read. Check it out.
Awesome. Any other questions?
All the SUSE tools always seem to work with Red Hat, just fine and everything else. It seems to be sometimes lacking on the Ubuntu side and Debian things. And that's been the real kind of sticking point because all of our Android developers are all Ubuntu and trying to unify unify everything behind a single tool or tool set is the lack of Debian stuff playing with RPM-based stuff is a challenge. I'm not sure if that's moving any forward on kind of supporting Ubuntu on the various tools.
It's been talked about. It causes a little bit of friction in some ways, but I think there is a certain level of recognition that Ubuntu Enterprise, I don't know if it is or not.
I think there's an admission that Ubuntu actually exists.
There's that too,
because it does, and I think it's an evolving conversation. Just real quick, I think it's context based though. When you say a particular tool exists on the Ubuntu distribution that doesn't exist, that's where we're very interested to learn. And how we can help people move to, a true enterprise distribution that has those tools.
Historically, where it came from is all the Android developers. It's like, well, Google uses Ubuntu. All the documents online use Ubuntu, so therefore I want my Ubuntu workstation so I can do Android development.
And there are a lot of documents, right? In fact, there's 500 documents at least on how to do something in Ubuntu. I mean, 400 might be outdated.
Which could be confusing, but
I mean, there's a lot of documents.
To that point though, being an RPM distribution, Red Hat being an RPM distribution, that makes that transition easy between SUSE and Red Hat. There are a lot of differences with Ubuntu, right? Their development is a little bit different. Their approach is much more different for enterprise than it is SUSE. Just that difference alone makes it a little bit difficult for adoption. I don't know if that is the whole reason, but it certainly slows things down a little bit.
Do you know if machinery supports Ubuntu? If it supports Windows, it doesn't seem like it should be hard to support.
If it doesn't support Windows, but it supports Ubuntu.
Okay, so that's one. Kiwi supports Ubuntu. OBS supports Ubuntu. So what, SUSE Manager does not support Ubuntu?
Correct.
And What else?
So
But I can tell
say
you,
I will say
there
this.
are,
I will say this. SUSE Manager leverages the upstream spacewalk code. There is still database extensions and content in the spacewalk code that's in SUSE Manager that has Debian pieces and parts in it. I know people who have personally got it to work. The tough part is not whether the packages can be served from that. It's the consumption and the client tools. So on the client, the host side, being able to interface apt-get with spacewalk plugins so the content delivery is sound. So that's really the rub. I'm not going to say it doesn't work because it does. It's just support, right? Support in that context. So.
Right. So I mean, it can be done. You can make it happen.
You can make it happen. It's just whether or not you have a throat to choke about when it doesn't happen, right? Right.
because we don't support it, right?
Right. So I mean, and when you're depending on it, is always the time it tends to not work for you. So it's just caution. So we err on the side of caution, and what we support is on the stuff that we can support. So.
Thanks, guys.
Yeah.
Thank you.